students, this is Junita Mukherjee once again in SS Public School giving you the notes about ray optics and optical instruments. In this particular chapter we will learn about the thin lens formula first. Okay, how we have to calculate the thin lens formula or the lens formula itself. So let us do that one. Okay, so in this particular thing, that is thin lens formula, we have a object given by AB. There is a lens, we have taken a convex lens into action, and this ray is passing through this and making an image in the opposite side of the lens itself, and it's bigger than the object itself, and it is inverted and real. Okay, so we have taken OF value. This is O to F value as F itself. This particular value F itself. Triangle A dash B dash O and triangle A B O. A dash B dash O and A B O. We have taken. So A dash B dash upon A B is equals to O B dash upon O B. Okay, this particular thing O B and O B dash we have taken. First equation. Again in triangle A dash B dash F. A dash, B dash and F we have taken, and A dash and triangle DOF we have taken. Okay, so in these two are the similar type of triangles. Okay, similar type of triangles, that is A dash, B dash, F and ODF. Okay, so A dash, B dash, OD upon is equal to F B dash upon OF. So it is A dash, B dash upon AB we can take, and F B dash upon OF we can take. So OD we have taken as AB. Okay, we have taken as AB. From question number 1 and 2 we can take that OB dash is equals to upon OB will be FB dash upon OF. Okay, and this will be OB dash minus OF upon OF itself. Okay. Now new Cartesian sign conversion is OP equal to minus U, OB dash is equals to plus V, and OF is equals to plus F. Substitute the value, that is U upon minus F, that will be V minus F upon F. Then VF is equals to U minus of UV plus UF, or UV plus UF plus minus of FV. Now dividing both sides by UVF, we will have UV upon UVF, UF upon UVF minus VF upon UVF. It will be equal to 1 by F is equals to 1 by V minus 1 by U, that is the lens formula. Okay, so in this particular relation, the focal length of the lens and the distance of the object image from the optical center of the lens itself, and O is the optical center and F is the principal focus of the convex lens of the focal length. OF is equals to F. AB is the object held perpendicular to the principal axis of the lens at a distance beyond the focal length of the lens. A real, inverted and magnified image is formed as shown in figure given below. Thus the lens, this is what we call the lens formula. So looking forward for yet another topic in which I will tell you the lens maker formula, how we are concluding. So let's see that lens maker's formula. Now let's see students, it's a lens maker formula, refraction of by a lens itself. Here the object is at O, near the image, okay, and this is particularly lens we have taken it in the middle. This is the N1, this is N2, okay, and this one is B, this one is D, and how it is going, the ray from this object is incident on this particular lens, and thus the image is there in the I1 forming, and thus this particular distance is R1 itself, okay, and here this is R dash, small R1, which is the refracted ray here. Here the incident ray is given by I, this is N1 and this is N2 here, and in this particular diagram we have taken that C2 here, C2 is there, this is R2 itself, okay, and thus this forming an image at I and there in I1 dash. This is the incident ray I2 and here the refracted ray R2 is there. Now applying the equation for spherical lenses to the first interface ABC. ABC we are taking A, B and C. This particular A, B, C we have taken. Okay. In this ABC case, okay, N1 upon OB, N1 upon OB, OB, this particular value. Okay, plus N2 upon IB1, I1B, I1B, this one equal to n2 minus n1 bc1. This is bc1. Okay. Then this is the first equation. Similar procedure applied to the second interface ADC. That is A and D is here, D is here and C here. Okay. So ADC, the second interface we are taking minus of ND, N2, minus of N2 upon DI1, DI1. Okay. Minus of N2 upon DI1 plus N1 upon DI1, DI, N1 upon DI. That is N1 upon DI, D2I will be equal to N2 minus N1 upon DC2. That is DC2 here. Okay. This is second interface we are taking. For thin lenses, BI1 is equal to BI1. BI1, that is BI1 is equal to, for the thin lens, BI1 is equal to DI1. So DI1 here we have taken is equal to DI1 we have taken. Okay. So now adding equation number 1 and 2, we will have N1 upon OB plus N1 upon DI is equals to N2 minus N1 IBC1 plus IBC2. From these two equations we have taken. That is from this and from this itself. Okay, suppose the object is at infinity, the OB is equal to infinity and ID will be equal to F. Okay, DI equal to F, D2I equal to F itself, and O to B, this O to B will be at infinity, it will be infinity. Okay. Now N1 F is equals to N2 minus N1, 1 upon DC1 plus 1 upon DC2. N2 minus N1, you know it very well. Okay, this is the formula we have taken from adding equation number 1 and 2. We are taking the equation number 1 and 2. If we add these two, we will get this particular value. And this particular value is given in here. So BC1 is equals to R1 we have taken and BC2 is equal to R2 we have taken, minus of R2. Substitute these two values in this particular equation. We will have this equation number 4 can be written as 1 upon F, 1 and 2 minus 1. 1 and 2 minus 1. That is, we have taken the refractive index here. So it will be equal to 1 and 2 minus 1. 1 upon R1 plus 1 upon R2. That is 1 and 1 is equals to N2 minus N2 upon N1. It is given by this particular value itself. That is N1, this particular value we have taken. Okay. So from this equation, we will be having this value. If we divide this, subtract this value and divide this value, or you can divide. We will divide the value by N1. If we divide the value with N1, we will get this particular value. Now this equation number 5 is the lens maker formula, which is we have got it from this particular derivation. Putting N2 by N1 equal to N, refractive index of material of lens with respect to its surrounding will be 1 upon F, N minus 1, 1 upon R1 minus 1 upon R2. From equation number 3 and 4 we will get third equation and fourth equation. We will get N1 upon OB plus N2 upon DI is equals to N1 upon F. Sixth equation, from B and B both are close to the optical center of the lens. So OB equal to minus IU and DI equal to plus V. Substitute the value and we will get 1 upon V, 1 minus 1 upon U is equals to 1 upon F. That is the lens maker formula here. Now the assumptions made in the derivations here according to the lens maker formula is the lens is thin so that the distance measured from the pole is its surface can be taken as equal to the distance from the optical center of the lens. The aperture of the lens is small and the object considered as a point lying on the principal axis of the lens. The incident ray, the diffracted ray makes small angle with the principal axis of the lens. A concave lens is made up of two convex spherical refractive surfaces. A first refractive surface forms by I1 of the object O and image I1 act as a virtual object for the second surface that forms in the image at I. So from this particular lens maker formula, it is clear that the focal length of the lens depends upon radii of the curvature of the lens and refractive index of the material of the lens with respect to its surrounding. So I hope so I have made you understand this particular lens formula, lens maker's formula and thin lens formula. So we will move on to the next topic in the next session, in which I will tell you about some of the values, some of the combinations of the thin lens. So looking forward for the next video. Till then, take care and thank you.